In this lesson, the target states, I can evaluate algebraic expressions. An algebraic expression looks like this. It's different from a numerical expression because it has a variable. And the variable can be anything. The other parts of the algebraic expression are called the constants. In this algebraic expression, the constants are 3 and 2. But to evaluate an algebraic expression, we need a value for the variable. So we can pick any number and put it in place of x. Let's say x is 5. If x is 5, we'll substitute in 5 for x's place and rewrite the expression and then use correct order of operations to solve the expression. That's evaluating it. So we're going to rewrite the expression with 5 in place of the x. Now it does not become 35 because the 3 next to the x means 3 times x. But remember, we don't use that multiplication symbol that looks like an x because we have the variable x. So it would be 3 times 5 minus 2. Correct order of operations says multiplication comes before subtraction. So 3 times 5 is 15. Rewrite the expression, 15 minus 2 equals 13. We have another algebraic expression that's a little more complicated because it has two variables and they're the same. So this algebraic expression has three constants, an exponent, 6 and 2, a couple different operations going on, but one variable. So if we pick the value of 2 for y, we would plug it in, rewrite the expression 6 times 2 squared plus 2 times 2. Now we have to use the correct order of operations. No parentheses. If I write PEMDAS out, no parentheses, there is an exponent. So exponents would come first. 2 squared is 4, so I'm going to rewrite the expression. 6 times 4 plus 2 times 2. Exponents are done. Multiply and divide comes next, and I have two multiplies. I'll do them both at the same time because they're what comes next. 6 times 4 is 24, plus 2 times 2 is 4. My last step is to add, I get 28. So evaluating it might be helpful to know how algebraic expressions can be written because sometimes that can be confusing. Let's look at a few of these examples from our textbook where it points out some of those things that could be confusing. When it comes to multiplication, sometimes we have two variables next to each other, like a, b. And what operation goes in between them is multiply. It means a times b. So if a were 2 and b were equal to 5, then ab would be 2 times 5 or 10. We can also write division a few different ways as well. Division can be written with a fraction bar, so this looks like q over 2, which is the same thing as q divided by 2, which could be written as q slash 2. So if q were equal to 12, then it would be 12 divided by 2, which is 6. So keep that in mind when you're evaluating algebraic expressions. Okay, here's a few for you to try. Click pause, copy down these algebraic expressions into your notebook, substitute in the value for the variable, and evaluate. Find the value of this algebraic expression. Number 1, n equals 6. Number 2, x equals 12. Number 3, d equals 2. Remember to use the correct order of operations. You might even want to write PEMDAS down in your paper to help you out. Click pause and try these out. Good luck. Now that you've had a chance to try these three problems, let's go over them and see how you did. Make sure you check your work as you go. Number 1, n over 2 plus n. So remember I went over this. This means divide. So hopefully you remembered that. So you could rewrite this problem a few different ways. I might rewrite it. 6 divided by 2 plus 6. And then use the correct order of operations. Division comes before addition. So it's 3 plus 6. 3 plus 6 is 9. So number 1, the answer is 9. Number 2, Just like number 1, there are two variables, but they're both x. But we're going to rewrite the expression, and we're going to substitute in 12 for x, so it's 12 divided by 3 plus 2 times 12. PEMDAS, multiply and divide, come before add, and they happen from left to right. So I'm going to do 12 divided by 3 and get 4, and 12 times 2 times 12 and get 24. And the last thing I'm going to do is add. So for number 2, I got 28. Number 3, last one. D equals 2. Substitute in the value of D. 4 times 2 squared minus 3 times 2. Hopefully you remembered that 3D is 3 times D. In this case, 3 times 2. It's not 32. So if we're evaluating this one using PEMDAS, there's no parentheses, there is an exponent, so I would do that first. 2 squared is 4. Rewrite the expression 4 times 4 minus 3 times 2. Exponents are done. Multiply and divide, well, there are only multiplications. So I'm going to do both of those at the same time, and I would get 16 minus 6, which is 10. So for number 3, I got 10. Check your answers. How'd you do?